Okay, so today we're going to talk about the last part of repeated measures, and we'll call it mixed design. In the textbook, it says mixed randomized repeated measure design, but I think it's so long and it can be a bit confusing, so we'll just call it mixed design. And there it is called mixed design. Different people call it different things, and I made sure to Google again yesterday. Um, yes, mixed design it does, and split plot is another term that is used um, for referring to this kind of design. So in essence, this is a popular design that looks at experimental studies where we have two randomized groups and they're measured over time. And so it's a mix between two different types of IVs. So one IV is based on between groups, so there's different people in different groups. And then the other IV is based on within subjects, within cases, and it's measuring over time. So for example, if I split the class into two, one you write a paper, one you take an exam, and then see, I don't know, course satisfaction or whatever over time, before, after, or stats, not course satisfaction. Let's say stats competency or self-efficacy, and then we rate it over time and then compare. So then part of it is between group, the part that takes an exam and the part that writes papers, and then there's also within subjects over time, comparing your baseline time 1, time 2, time 3 efficacy scores. So so this is a graph, a figure that sort of illustrates this pre-test, post-test control group design. So people are randomly assigned to two groups, and one has one treatment, the other is a control group, or it can be another kind of treatment, and we observe, measure over time. So I'll just give you some examples to better illustrate what they're like. One example is to examine the effectiveness of three types of treatment: individual therapy, group therapy, and waitlist control group. And we examine by looking at baseline, post-treatment, 3-month follow-up, 6-month follow-up on their eating disturbance scores. So this is the study. And in the next exam or the next two exams, I'll be asking you some of these similar types of questions. So we'll use this as a practice. So this is the study. And what's the randomized group IV here?
Therapy type?
Yes, that's therapy type. So different people are assigned to the different types of therapy. And then what is the repeated measure IV?
The time and follow-up?
Yes, so time and follow-up, so baseline, post-treatment, 3 months, 6 months, so time. And what are the cases? I don't think I often ask this question, but I think sometimes cases can be products or cities and stuff, especially around marketing. So in this case, the cases are people, right? So they're the patients. And then what is the DV?
Eating disturbances.
Yes, eating disturbance score. So this is an example for split plot, mixed design. This is another example. So pharmaceutical company tests effectiveness over several hours of the new anxiety drug for patients with 3 different types of disorders: social anxiety, generalized anxiety disorder, and OCD. So in this case, what would be the randomized group IV or the between group IV? Yeah. What?
Goes, right? I think.
I said who gets the drugs. Randomize who gets what drugs.
Okay, so maybe this is a bit let's take out the randomized. What's the between group IV?
Social anxiety, general anxiety disorder, OCD.
Yeah, so the type of disorder, yes. And what's the repeated measures IV? Variable. Time, yes, so assessed over several hours. And then what's the cases? People, so whoever gets the medication. And what would be the DV?
Effectiveness of the drug.
Yes.
Anxiety?
Yeah, so anxiety scores would illustrate the effectiveness of the drug. So it depends on how effectiveness of the drugs is operationalized. So it could be anxiety scores. Yeah, so I think you sort of have a sense of how to take apart these kind of questions. So here are some advantages of split plot designs. One is generalizability. It allows us to see whether the repeated measures IV produces the same pattern of results with different levels of the randomized group IVs. So it's kind of like the factorial designs, where we looked at a certain pattern across another IV, and then we say, okay, is this consistent across both groups, or it depends on whether men or women, whether you've taken a lot of stats class before or not so many stats class. And so the difference is we're looking at the generalizability of a repeated measure IV. So we're looking at maybe like over time, is this pattern same across two different groups? And another advantage is that we have increased power. So we talked about using repeated measure. Part of the error is taken out because it serves as its own control. And so that yields a larger F. So smaller error terms associated with the repeated measure segment of the design. I'll talk more about the different segments of this design. However, there's also disadvantages, but the disadvantages is more about the complexity. So you need to fulfill more different kinds of assumptions. So you need to fulfill assumptions related to repeated measures, assumptions related to between group designs. And then there's separate error terms used for the two types of analysis. So later on today, we're going to run SPSS, and then we're going to look at different tables. And then in the data that in the results that we're going to interpret, we're going to be looking at, it will involve error terms from different tables. So it's a little bit more complicated. So what I'm going to do is I'm going to give you an illustration. We won't do any hand calculations, but I'm just going to give you some illustrations for you to get a sense of the sum of squares and what parts are involved. So there's different parts of sum of squares now. So it's going to split between two parts. One is the between group part, or the randomized between group, randomized groups part. And then the other part is going to be the repeated measure part, the within subjects part. So under the between group part, we're going to have a between group sum of squares and the within group sum of squares. So we're going to have a ratio like what we did for the one-way ANOVA. And then for under the repeated measure part, we're going to have the sum of squares for the repeated measure IV, which we'll use B. And then we'll have a sum of squares for the interaction. And then we have it's within group, within subject error term. So this will be used as an error for these two parts. And related to that are the degrees of freedom. So total degrees of freedom would be total sample size minus 1. And then here are the formulas for the different degrees of freedom. So for the sum of squares between group, degrees of freedom is A minus 1. So that will be the level of groups, the number of groups between groups. So if it's cyclodynamic, CBT, and control group, A will equal 3. And the degree of freedom will be 3 minus 1 will be 2. And then for the error term, it's A times S minus 1. number of subjects in each group. So, if we had 10 subjects in each group, and then 3 groups, so it'll be 3 times 9, and that'll be 27. And for the repeated measure part, it's also the level of the repeated measure IV. So if it's measured over 4 times, it'll be 4 minus 1. We'll have a degrees of freedom of 3 here. And then for the error term, it's A times B minus 1 times S minus 1. So if it's A is 3 times 4 minus 1, that's 3. 3 times 3 times 9. That we'll have a degrees of freedom of 81. And for the interaction, it's A minus 1 times B minus 1. So, and what we'll do is when we run the SPSS, I'll show you where the degrees of freedom is, and then we'll go through this and hope it makes sense. So like, okay, this is why there's a 20 here or 18 here. Okay, so we're done with the conceptual parts in terms of degrees of freedom and the sum of squares. So just want to give you an illustration of what's different between a mixed design and a factorial design. So here are what the two looks like. So a factorial design is when both IVs are between group IVs. And so we can see that in cell A1, B1, there are 3 participants. In cell A1, B2, there are 3 different participants. So S1 is subject 1, S2 is subject 2, S3 is subject 3. So in each of these cells, they are different participants. So we have a total of 12 different people. And for the mixed design, we have one IV that's within subject and one IV that's between groups. So for the IV that's within subjects, it's like time 1, time 2. They're the same people. So it's subject 1 measured at time 1, subject 1 measured again at time 2. So these are the same people, and these are the same people. So in this design, there's only a total of 6 different people, but they're measured across 12. There's 12 data set points. And here there's 12 data points, and they're measured with 12 different subjects. Does that make sense? Okay. So now we're going to do an SPSS practice, and this is going to be the mixed design study. So students are randomly assigned to read sci-fi, mystery, or romance novels during a period of 3 months. So it's pretty similar to what we did on Monday. But the main difference is that they're randomly assigned to read one of these 3 genres. So they're not the same people. So what we did last time, it was like same set of students and looking at how many sci-fi books and mystery books they read over time. But now there are 3 different set of people. And then so in this study, what would be the randomized group IV?
Sci-fi mystery genre.
Yes, genre, so type of books. What would be the repeated measures IV?
A period of months.
Period of months, time. How about the DV?
Number of books read.
Yeah, number of books read, and the cases are the students. Yeah.
Students.
Okay, so this is the data set. So what I'm going to ask you to do is to prepare the data, open up a new file, and prepare the data. And so these are the number of books read by those that were assigned sci-fi in month 1, and in month 2, month 3, and mystery, month 1, month 2, month 3, and romance, month 1, month 2, month 3. Okay, so I'll let you set up the data, and let me know if you run into any questions. So